Hi, my name is Anish Das Sarma, and I'm going to give you a very quick overview of our paper titled Exploiting Lineage for Confidence Computation in Uncertain and Probabilistic Databases to appear in ICDE 2008. This work was jointly done by me, Martin Theobald, and Jennifer Widom, all from the Stanford InfoLab. The TRIO project at Stanford is building a DBMS for managing data, uncertainty, and the lineage of data. And in our paper, we address the problem of computing confidence values in TRIO's data model that's called ULDB, which stands for Uncertainty Lineage Databases. In the paper, the specific question we address is how can we use the lineage feature in ULDBs to make confidence computation more efficient. Let me give you a very quick example to describe the ULDB data model. As you can see here, we have tuples, but these include confidence values which denote the uncertainty in whether the tuple is present or not. We have two relations here. In the first relation, tuple 11 says that Amy saw a Honda. Notice that this is associated with a confidence value of 0.5, which means that the tuple has a 50% chance of being present in the database. So here I'm going to show you how lineage is generated when you do a simple join query of these two relations and project onto the person attribute. The result of this query is shown here, where you have three tuples. Lineage tells you how each of these tuples was produced. The first tuple Jimmy was produced by joining tuple 11 from the first relation and tuple 21 from the second relation. So its lineage, denoted lambda of 31, is 11 and 21, which means we need tuple 11 and tuple 21 to be present for tuple 31 to be present in the result. And similarly, the lineage of the remaining result tuples are computed. In the example shown here, all tuples in the results have conjunctive lineage. However, in general, lineage could be an arbitrary Boolean formula over input tuples. Once you perform a query, we want to know what the confidence values on result tuples are. At first glance, it might seem that confidence computation is an easy problem and you can propagate confidence values operator by operator through a query plan. However, previous work has shown that this cannot be done for all queries. We take a slightly different approach in confidence computation in ULDBs. It is based on the key observation that the confidence of a tuple is a function of the confidences in the lineage of this tuple. This allows us to very nicely decouple data and confidence computation. Specifically, we can use any query plan to compute the data portion in the result of every query, and then we use the lineage to compute confidences on demand. Suppose we have a relation R and a tuple T whose confidence value we want to compute. The confidence of T is computed using the following steps. First, we expand the lineage of T to base tuples. So let's say T was derived from S1 and S2. We further find what these tuples were derived from. So if S3 and S4 resulted in S2, we replace the lineage of T in terms of S1, S3 and S4, and so on until we reach base tuples. At the end of this process, we have the lineage of T in terms of base tuples. The second step is to compute the confidence values based on the confidence values of these base tuples. So we get the confidence values of the base tuples and then finally evaluate the probability of F using these confidence values. In the paper, we show several improvements to this naive algorithm. First, we can memorize confidence values, which is an obvious improvement. Whenever the confidence value of a tuple is computed, we can save it in the database. The second improvement is slightly more subtle, which says that we can exploit independences between tuples whenever there is independence. In our example, S1 and S2 were independent of each other as they did not share any common tuple in the lineage. So we could have recursively computed the probabilities of S1 and S2 and then use that to compute the confidence of T. In the paper, we show several other results which I have not been able to present. These include details of the query processing algorithms as well as more efficient algorithms if we want to compute confidences for a batch of tuples. We give experimental results as well as extensions to the data model. I would like to also quickly advertise several other pieces of work we have been doing in the Trio project. First, we have an open source DBMS system which you're welcome to use. Then we have some very interesting results on data modifications and versioning, schema design and dependency theory, and other work as well. Thank you for listening.